Hello. This video is primarily for juniors who are working on the work keys this morning. This lesson is on graphing sine and cosine graphs. In first hour, we started a little bit of this last Monday. Third hour, we did not get to it, so if you saw part of this on Monday, you can fast forward to the new part. That's fine with me. So graphs of sine and cosine come from the unit circle. So we're going to fill in like an XY table. So in this case, X is the different angles as you go around the unit circle. And then Y is equal to either the sine of that angle or the cosine of that angle for the sine and cosine graphs. Okay. So over here on the unit circle, let's just quickly review. The coordinates are 1 in the X direction, 0 in the Y direction. Up here, 0 in the X direction, 1 in the Y direction. Over here, -1 in the X, 0 in the Y. And down here, 0 in the X, -1 in the Y direction. Okay? So we'll start out with -2 pi. So negative angles go clockwise. So if I go clockwise 2 pi, I'm going to end up where I started, right? And so the sine value there is the Y coordinates, which is 0. -3 pi over 2. So if you remember, positive 3 pi over 2 is like 3/4 of the way around the circle. So if I go that in the opposite direction, we'll end up at the top of the circle. Sine value there is 1. -pi, so that'd be halfway around the circle in the clockwise direction. Sine value there is 0. -pi over 2 would be just clockwise 90 degrees. Sine value there is -1. 0, we're back to where we started. Sine value is 0. And now we're going in the positive direction, so that's counterclockwise. So at pi over 2, sine value is 1, pi, 0, 3 pi over 2, -1, and 2 pi, we're back to 0. Okay. So there's a pattern here that's going to repeat over and over and over. It goes 0, 1, 0, -1. And it starts over. 0, 1, 0, -1. And if I kept going around the circle and stop after every pi over 2, I'm going to be hitting these same points over and over. So those Y coordinates are just going to repeat. Okay. So this is an example of what's called a periodic function. Periodic function. And a periodic function is where there's a pattern that repeats over and over. Okay, so then let's plot these points on our graph here. So each tick mark I'm going to make pi over 2 on the x-axis. So there's pi over 2, pi, 3 pi over 2. I'm not going to label every single one. That would be 2 pi. And the same thing in the negative x directions, that would be -pi, that would be -2 pi. And the y direction, I just need to go up to 1 and down to -1. Hope you can see that okay on the video. Okay, so now we're going to plot points. So when x is negative 2 pi, y is 0. So if y is 0, then we're right on the x-axis there. When x is negative 3 pi over 2, now we're at positive 1. And negative pi, we're back down to 0. At negative pi over 2, now we're down at negative 1. And then it goes to the point 0, 0. And then it repeats. Positive 1, 0, negative 1, 0. Okay. And maybe you've seen the sine graph before. Sometimes it's referred to as like a sine wave. So when you draw this, draw it like a wave, like in the ocean, like a nice gentle wave. Okay, so what I don't want to see, I don't want to see a zigzag. So these are not like straight lines. I mean, it looks like you could just connect the points in a straight line, but that's not what it looks like. So we want to draw a nice gentle wave. Just like you're at the beach. Something like that. Let me shift that up maybe a little bit. Shift that up a little bit. There we go. Okay. So that's just the basic parent function, so to speak, for y equals sine x. Okay, then let's kind of take a closer look at the graph here. So the period, so we said it's a periodic function. The same pattern repeats over and over. So the period is how often the pattern repeats. That's the period. Okay, so if I look at, let's say, start at 0 here. So starting at 0, I go up, I get to 1, I come back down, I go down to negative 1, and then at this point here, 2 pi, which is once around the circle, then I'm going to start going up again. Okay, so the period here would be 2 pi. That's how long it takes in the x direction until the pattern repeats. 2 pi. Okay. We have not talked about domain and range for a while. So remember, domain is possible values of x. So x can be anything. This is a continuous function. There are no holes or asymptotes or anything like that. So the domain would just be all real numbers. So as far as how you write that, so you could use the all real numbers symbol, or if you want to use interval notation, negative infinity to infinity. Either one of those would represent all real numbers. Range is possible y values. So for this function, the highest that the y value is going to get is 1. And the lowest it's going to get is negative 1. So we could write that either as an inequality. We could say negative 1 is less than or equal to y is less than or equal to 1. Or we could write it in interval notation, negative 1 to 1. And I guess I would want to have brackets, because it can equal negative 1 or positive 1. Okay, the amplitude. So in this graph, the x-axis represents what's called the midline, which kind of cuts the graph in half between the top and the bottom. So then the amplitude is this distance from the midline up to the maximum. That distance right there, that's the amplitude. So going from the midline up to the maximum, that distance is 1. Okay, so the amplitude here would be 1. Then our x-intercepts. So if we look at where this crosses the x-axis, -2 pi, -pi, 0, pi, 2 pi. Next one's going to be at 3 pi, 4 pi, 5 pi, so on. So those are all multiples of pi. So the way we'll write that, we'll say it's pi times k, where k is an integer. So integers can be positive or negative. But they're positive or negative whole numbers, basically, 0. Okay, the y-intercept crosses the y-axis at 0. Maximum value, so how high does the graph get, goes up to 1. And the minimum value is -1. Hope that makes sense, because you're probably watching this on your own and there's no one else really to talk to. Yeah. So if you'd like to hit pause and then try to do the cosine graph on your own, why don't you do that? And then you can hit play and see how you did. It will be a similar graph. So I'll go ahead and hit pause. Okay, let's see how you did there. So now I'm looking at the x-coordinates as I go around the unit circle. So cosine is at 1. Then I'm at 0. And we're at -1, 0. And then that pattern is going to repeat. 1, 0, -1, 0, 1, 0, -1, 0. So it's the same pattern that the sine function had. It just starts at a different point. The sine graph starts at 0, the cosine graph starts at 1. Okay. So now if we plot those points for cosine, so that's 2 pi. 1, 2, 3, 4, that's -2 pi. And we're at 1 and -1. Okay, so we're starting at 1, 0, -1, 0, 1, 0, -1, 0, 1. Okay, and again, when you draw the cosine graph, make sure it looks like a wave as opposed to a zigzag. Maybe shift that up just a little bit. Okay. So similar shape. The only difference is basically the whole graph is just shifted, right? So then if we look at these attributes, most of them are the same as what they were for sine. So the period, if I start at 1, go down, come back up, by the time I get to 1 again, that distance there in the x direction is 2 pi. Domain, still all real numbers. Range, still going from -1 to 1. Amplitude, from the midline up to the maximum, that distance is still 1. Guess the couple things that are different are the intercepts. Okay, so for the sine graph, it crosses at multiples of pi. Here we're crossing at pi over 2, 3 pi over 2. The next one would be 5 pi over 2. So now we're talking about like odd multiples of pi over 2. So a couple ways to write that. Probably the best way to write it is to say pi over 2 plus pi times k, where k is an integer. So the first one's at pi over 2. And then if I add pi to that, so I'm going like halfway around the circle. So pi over 2 plus 2 pi over 2 gives me 3 pi over 2. And pi is like 2 pi over 2. So if you just add 2 pi over 2 each time, you're going to get 3 pi over 2, 5 pi over 2, and so on. Okay, y-intercept is now at 1. Maximum value is still 1, minimum value is still -1. Okay. So those are just like the basic parent functions for sine and cosine. Now let's see what happens if we multiply the function by a constant. Let's use our calculator for this. So graphing sine and cosine functions on your calculator. So obviously you would type in your function. So I'm typing in 3 sine x. You're going to need to adjust your window to see a graph similar to what we've been drawing. Why don't we also graph just regular sine x, so we can compare 3 sine x to sine x, see how it's different. Okay, so then go to window. So in the x direction, look at the first graph we did. So we had it going from -2 pi to 2 pi. So let's do that. X minimum is -2 pi. And then if you hit the down arrow, the calculator is going to actually multiply together. 2 times -3.14. So that's -2 pi. And then we've got +2 pi. And then for the scale, so these tick marks were like pi over 2 apart. So we could put pi over 2 in for our scale. Okay, then minimum. So let's go -5. I know we didn't need that for the first graph, but we will need that for this next graph. And the y maximum can be +5. Okay, so we're almost there. So the units we've been using here are radians, right? pi/2 radians is quarter of the circle. Okay, so we'll go to mode, and we're going to want to switch to radian mode. So those of you that haven't taken the quiz yet, make sure you switch back to degree mode for the quiz, or you'll get several wrong answers. Okay, so now we're graphing. Okay, so that's actually the new graph. There goes our parent function right there. So this is 1, this is -1. So the parent function is the flatter of the two. So then what happens to the graph when we do 3 sine x? So it changes the amplitude. So the amplitude is now 3. Changes the maximum and minimum values. Okay, but notice the x-intercepts are the same. The y-intercept is the same. The period is the same. So all that changed was the amplitude. Okay, so if you want to sketch that. So 2, 3, 4, 1, 2, 3, 4. So this is 2 pi, -2 pi. And 1, 2, 3. -1, 2, 3. Okay, so this is a sine graph. So sine graphs, kind of remember this. This is kind of key to graphing. Sine graphs start at 0, 0. Unless there are some shifts, which is what we'll do tomorrow. So it starts at 0, 0, then it will go up to 3, down to 0, down to -3, back to 0. -3, 0, +3, 0. Okay. And you will need to graph these without a calculator. So we're kind of using the calculator just for some initial investigation. But don't think that you're just going to be able to use your calculator for every single graph. Okay. So then if we have -3 sine x, so think back when we put a negative in front of like any graph, what does that do? So it's going to cause a reflection, right? Let's scale back up there. 1, 2, 3, 4, 2. 3. Okay, so it's still going to go through 0, 0. But now instead of going up towards the maximum, as I go to the right, it's going to go down to the minimum. So it's going to go down to -3 first. Then goes back to 0. Then it's the maximum. And back to 0. So maximum, 0, minimum, 0. And hopefully when you draw that in, it looks like a reflection of the first graph. And maybe I should have made a note back here, so the amplitude is 3. So So for the second one, the amplitude is also 3. The negative sign causes a reflection over the x-axis. Reflection over x-axis. Okay, let's see if we can do this cosine graph then, like without the calculator. Okay, so think about where the cosine graph starts. So the cosine graph doesn't start at 0, 0. So normally it would start at the maximum value, and then go down and come back up. Okay, but then we've got a negative 3 here. So instead of starting at the maximum value, that's going to be reflected. So you're going to start at the minimum value. Go up from there, so go up to 0, up to the maximum, 0, minimum. So it's like you always got these 4 points. You got a couple of times where it's 0, and then where it hits the maximum, where it's the minimum. So as long as you start in the right place, that's about it. Okay. Okay. So that's adjusting the amplitude. So we'll go back to our calculator for this. Okay, so now instead of multiplying like outside the parent function, now we're going to multiply inside the parent function and see how that affects the graph. Okay, so graphing calculator. So I've got my parent function in there still, so I'm going to make my first equation here sine of 2x instead of 2 sine x. And you'll see that that's definitely not the same graph. So a graph here. Okay. So now the amplitude is 1 for both of them. So the amplitude doesn't change. But the x-intercepts and the period, those did change. So on here, the boulder curve is the parent function. So now the period, I'm going up, down, back up, all in a distance of pi. Okay, so the period changed from 2 pi to 1 pi. So let's sketch that. So it's 2 pi. 2 pi. 1, negative 1. So I guess I can draw in, so let's do the parent function first. Parent function, so 0, 1, 0, negative 1, 0, negative 1, 0, 0. And feel free to pause if I'm going too fast for you here. Oops. Okay, so that's our basic sine graph. Starts at 0, goes up to 1, so on. Okay, so now sine of 2x. So the period is now just pi. So I've got to get in one of these full cycles going up, down, back up in half the distance. Okay, so your sine graph, you got your starting point at the midline. Halfway through the period, it's hitting the midline, and then it ends at the midline. Okay, so if I think about the same thing, so halfway through the period, it's going to be at the midline. So then like halfway between there, it's going to be at the maximum. And halfway between these 2 points, it's going to be at the minimum. So one period would go like that. And then I could repeat that. And we could do that once over here. Okay. So here the period is pi. Okay, then let's look at the sine of 3x on your calculator. So we can probably guess the period is going to change again. So there it is. Okay, so the period, it's not quite so obvious here, so it's kind of between tick marks there, so it's between pi/2 and pi. If we look at like how many times it repeats within like this 2 pi distance, so there's 1, 2, 3, so there's 3 cycles within 2 pi. So then if I just take 2 pi and divide by 3, because there's 3 of them, so the period for each one has to be 2 pi over 3. And so here the period is 2 pi over 3. And I'm not sure I want to draw that. The graph's going to get pretty crowded here. So I guess the important thing is just seeing like how this number changes the period. So if we have a general equation, a sine of b times x, so the period is going to be 2 pi divided by b, where b is this number that you're multiplying x by. So the original parent function, b is 1, so 2 pi over 1 is 2 pi. In this example, b was 2, so 2 pi over 2 is just pi. Third example, b was 3, so 2 pi over 3. Okay. And then we also talked about the amplitude. So the amplitude is the absolute value of A. The amplitude is always a positive number. So A could be negative if there's a reflection, but when you say what the period is, or what the amplitude is, it will always be positive. I think on your homework it also asks you for something called the frequency. And the frequency is just the reciprocal of the period. So that would be b over 2 pi. Okay, so then let's work through some examples. So identify the amplitude, period, frequency, and sketch a graph. Okay, so the amplitude is the absolute value of A. So that'd be 6. The period, 2 pi over 4. We could reduce that to pi over 2. So the frequency, just flip that, 2 over pi. And now we're sketching a graph. Okay, so the amplitude kind of tells us our maximum and minimum values. So maximum value would be 6. Minimum value would be -6. The period is pi over 2. So let's just adjust the scale a little bit instead of trying to cram a whole bunch of cycles into a small space. So you can set your scale to be whatever you want. So let's just set the scale to be so that this is pi over 2. Okay, and then kind of 4 points. Well, after the starting point, we need 4 points to make up one period. So remember, cosine graphs start at either the maximum, or in this case, it's going to start at the minimum. It's going to start at -6. And we're at 0, 6, 0, -6. So one period ends at pi over 2. 0, 6, 0, -6. Okay. So then we do not need to graph the rest of these. This can be a little tricky. So the question is, what is the period? And so the period is 2 pi over b. Okay, but the tricky part is what b is here. So b is what we are multiplying by x. Okay, so I could write this as the sine of 1/10 x would be the same as x over 10. Just like pi over 2 and 1/2 pi are the same thing. Okay, so the b value here is 1/10. So the period is going to be 2 pi divided by 1/10. And some of us need to review how to divide by a fraction. When we divide by a fraction, we multiply by the reciprocal. So 2 times 10 is 20 pi. Okay. Example 4. Describe the graph. Okay, so when there's a negative sign inside the parent function, instead of a reflection over the x-axis, it's going to be a reflection over the y-axis. Reflection over y-axis. Period would be different from the parent function. 0.5 is 1/2. So if I multiply by the reciprocal, the period would be 4 pi. Okay, last example. Write an equation for a cosine function if the amplitude is 4 and the period is pi over 6. Okay? So my general equation should look like this. A cosine b times x. So A is connected to the amplitude. So A could be 4. What else could A be if the amplitude is 4? A could also be -4, and it would still have the same amplitude. Okay, so we're going to put plus or minus 4. So it could be either one. Now we need to calculate B. So again, we're using this formula. The period is 2 pi over B. So in this case, pi over 6 is equal to 2 pi over B. So cross multiply, solve that equation for B. If I cross multiply, I get B times pi equals 12 pi. Divide by pi, the pi's cancel out. So B is equal to 12. So my equation would be y equals plus or minus 4 cosine 12x. Okay, so your homework is on page 392, numbers 1 through 27 odd, and 29 to 34. And ideally, you do this before class on Friday. This Friday, we're gonna do more with sine and cosine graphs, and it'll be much more difficult to follow along with that lesson if you don't have a basic understanding of this. Okay, thanks for watching, and enjoy the rest of your day or evening, depending on when you are watching this video.